Good afternoon. We hope you have been enjoying World Space Week. Thank you for joining us for our live talk with STEM Ambassador Katherine, a former Chief Executive Officer for the UK Space Agency. She's also chair of the Global Network on Sustainability in Space, which brings scientists together to understand and tackle the problem of space debris. And she's also the founder of Primary Space, which you can see I've put the website details in the chat, so do take a look. Which inspires people like you to build our future in space. So we are delighted that she has given up her time to speak to us this afternoon. It's great to see so many schools joining us today from all over the country. Marsh Gibbon School, St Mary's School. Oh, there's just so many of them. So you're in for a real space treat this afternoon, as Katherine will explain why she cares so much about space and why we should all care about protecting the space environment. She'll be sharing satellite facts, explaining why the low Earth orbit is becoming more and more congested, and she'll also talk about the types of jobs people have working to protect this unique space environment. You'll have the opportunity to ask questions, so pop them into the chat. Some of you have done already, so thank you. And Katherine will aim to answer as many as she can at the end of the talk. You can also email us any questions post-event to ask an ambassador, also in the chat. So you don't want to hear from me. That's enough. I will hand you over to Katherine. Good afternoon, Katherine.
Good afternoon, Lisa, and happy World Space Week, everybody. As Lisa said, I'm going to talk to you about space junk, why I care about it and why I think you should care about it. The first thing that I want to do is just, as usual, you get the technical problem, is just to tell you a little bit about this picture. My home, my neighborhood is in Brighton. That's where I live. And this is a picture of Brighton from a satellite, taken from a satellite. What I like about my neighborhood is that it's near the sea. I love going down to the sea and looking out at the windmills that we have there generating clean energy. And there's a lot of green space. You can see that from the satellite picture. But it's actually still a city. So there are a lot of people living in the city, and we all have to be able to share the space together. So some of the things that I try and do in order to keep my neighborhood nice and to share it with the other people who live there and work there is to recycle as much as I can. And I also, when I'm traveling around, I just try and share the pavements and I try and share the roads and be careful not to bump into people. I'm sure you've got things you like about your neighborhood. It might be fun, if your school has the ability to do that, to look at satellite picture of your school in your neighborhood sometime. Now, Brighton is part of a wider neighborhood. It's a wider neighborhood that is the UK, and that is in the continent of Europe, and that is on a planet called the Earth. I'm sure you will recognize this picture from space. Also, thing to think about is that Earth is actually part of a much wider neighborhood. So this is the Earth's wider neighborhood. It's called our solar system. And you can see that Earth is that little blue planet on this picture. That's the third ball over from the sun. Now, actually, sometimes when people talk about the Earth, we call it the third rock from the sun. Now, this is the usual way that we look at the solar system, trying to count the planets, in the order that they are in the distance from the sun. But it's not necessarily a very representative, a very clear picture of what our solar system is like, because actually our star, our sun, is massive. It is absolutely massive. And if you look in this picture, there's a tiny little thing down in the corner that looks a bit like the size of a pea or a peppercorn, and that is the actual size of our sun in comparison to our Earth. And one of the things that I like to think about is that even though we're actually quite a tiny little planet, orbiting our sun, what we are is quite special. Some of the things that are special about Earth is that we are covered in water. And we are covered in life, in living things. And so far, as we know, we haven't actually been able to see any other planets, nowhere nearby anyway, that is as special as Earth in that way. Earth and our solar system are part of an even bigger neighborhood. So our bigger neighborhood is the Milky Way galaxy. And if you see where that arrow is pointing, that arrow is pointing to where our solar system is in the Milky Way galaxy. And this is, a picture that we've been able to take of our galaxy from telescopes. And what it shows is that actually there are something like 2 to 400 billion stars in our galaxy. And there's some information on this picture that I find really interesting. So scientists have so far identified, it says here 500 million stars, which may support life, but actually they've absolutely identified over 3,200 other stars in the Milky Way that are a lot like our sun. And they definitely have planets orbiting around them. Some of those planets are in an area called the Goldilocks zone. So if you remember the story of Goldilocks and the three bears, Goldilocks was always looking for the temperature and the location, the position, and things that were just right. And scientists call the area around a star that is close enough that it's warm enough to have liquid water and not just frozen ice, but far enough away that that planet's water isn't constantly too hot and constantly evaporating into steam. So the Goldilocks zone is an area where planets are orbiting their star, their sun, in a position that makes them able to have liquid water. And that means that they could have life, and they could have life not dissimilar to Earth, because that's what supports the water on Earth: water, oxygen, and the other essential elements that we have here on our planet. So, are we the only life in the observable universe? So here's a picture from the Hubble telescope, and we are very lucky to have the James Webb Deep Space Telescope has just recently launched and is sending back even more amazing and beautiful pictures of the universe that we can record, that we can see. There are about 2 trillion galaxies in the part of the universe that we can watch, that we can see. And if you take an average of about 100 billion stars in each of those galaxies, there are about 200 billion trillion stars in the observable universe. And scientists estimate that every fifth star, so if you look around your class group there and you look at every fifth person, for every group of 5, one of those people could be a planet that might have the ability to support life, that would be orbiting around its star in the Goldilocks zone. So just think about how amazing we human beings are, because not only have we invented this ability to look out into deep space and learn about it, we are curious animals, we have amazing ability to learn, to discover, to invent. But actually, as far as we know, we are the only species of animals that have ever been able to go out of their natural habitat in a very short period of time and explore space. And one of the things that allowed us to do that was the invention of satellites. So I want to talk to you about satellites. Here are a couple pictures of satellites. Satellites come in all shapes and sizes. When they were first invented, which was the first satellite to leave Earth, was called Sputnik, and it launched in 1957, and it was just a big metal ball that was probably the size of most of your classrooms. So it was quite big, but all it did was send back a little radio signal that went ping, ping, ping. But actually, it was such an amazing technological and scientific breakthrough that hundreds of millions of people around the world sat by their radios listening to that sound. because it was so astonishing that we could go through the Earth's atmosphere and put something made by human beings out into orbit around the Earth. And since then, since that time, more than 13,600 satellites have been launched into space. And there are currently around 8,850 satellites orbiting the Earth, now in October 2022. But only about 6,600 of those satellites are still working. The rest aren't working. And so I want to talk to you about those a little bit later. But first, I want to talk about this. I want to talk about why we should care about satellites. I show all these pictures on here because pretty much everybody will have heard of some of this. People probably have heard of weather forecasting, and they understand that, ambulances and fire engines and police cars use sat-nav to find their way to the emergency. They've probably used Google Maps at some point. Maybe they've watched a bit of satellite television. They've probably seen or used a mobile phone or some of these services online that actually require you to know where things are. And whenever Uber delivers or Just Eats or any of the grocery stores during lockdown, delivers something to your house, they are using a satellite to find your house. And what I think is so amazing is that all of us just walk around every day not realizing actually that all these things that we use every day in our everyday lives actually depend on satellites to work properly. If the satellites that give the signals that tell the fire engines and Just Eat and the food delivery services, where they're meant to be going, if they stopped working, we would all be back in a time when we had to get out paper maps and try and read the paper map and figure out how the thing on the paper represents what we're actually seeing as we're driving down the street. And I can tell you, I am old enough to say there were a lot of people getting lost when that was the only way you could do that. So satellites are incredibly special, and we really do rely on them for our everyday lives. One of the really important things that satellites do is they help us understand the Earth's environment. And this is a picture of a place in Wuhan, China. And on the top, you can see what Wuhan looked like from satellites that had special scientific sensors on them that gathered information about the quality of the air over Wuhan, China. And I don't think that air in the top part of the picture, which was the beginning of 2019, January and February 2019, I don't think that air looks very clean. I think it looks actually pretty polluted. But you can see from the same satellites, the same pictures, the same data that was gathered, the same information in January and February 2020. Now, you're all probably maybe a little too young to remember what was going on at that time. But I think some of you will remember that you maybe weren't in school in 2020 because we had lockdown. But Wuhan in China was the first place where they discovered coronavirus, and it was the first place that had lockdown. And what I think is remarkable about this information from space about the Earth is that two things. First of all, I think it's amazing that we can measure the quality of the air and measure the health of our planet from satellites like that. But also, I think it's amazing that nature, if you leave it alone, if the human beings stop going out and driving their cars and their trucks and you close down the factories, it will clean itself up. And so that's one of the reasons I think satellites are so important. Here's another example, actually. Another example is how we're trying to understand climate change and how to do a better job of looking after the Earth. These are two pictures of a big lake in Iraq. And the first picture with the blue, lovely water was taken from a satellite in April 2017. The second picture was taken in April 2022. And you can see what's happened to this lake. This lake used to provide drinking water for a whole city, a city called Samawa in Iraq. And it used to be a place where Migrating birds who were traveling from place to place as the seasons changed, they would come there because it was such a healthy habitat. They would stay there for a while. And now it looks like a mud puddle because of drought, because it's so dry there now, because of climate change, that actually there's really no water left. And this is not a picture from a satellite, but it's a picture that I would really like people to think about. This is a picture of the oceans. And I like to ask, when I talk to schools, I like to ask people the question, where did these 5 trillion pieces of plastic junk come from? Who put that junk in the ocean? And the answer, of course, is that we did. We put that junk in the ocean. We didn't do it on purpose, though. We didn't realize that when we throw plastic away and we're not careful and we don't recycle, that actually we're going to cause a big problem for the planet that we live on. Now, here's my mystery picture. And I was actually talking to the person who took this picture last night, which was fun. This picture was a picture taken by the British European Space Agency astronaut, Major Tim Peake. He went to the International Space Station in 2016, and some of you or your parents, you know, or your brothers and sisters might have watched some of the information on the telly about Major Tim Peake when he was up at the International Space Station. But one of the things that he liked to do is there's a big window in the space station where the astronauts get to have some relax time. And when they're on a break, he liked to take pictures outside the window of all the beautiful things he could see of our planet and of space. But this time he took a picture of the glass in the window. And that glass in the window is very, very thick. It's very thick. It's about 4 centimeters thick. It's made out of unbreakable glass. Well, unbreakable, you know, safety glass, let's call it. And that glass is see-through, but it's safe enough for the astronauts. It protects the astronauts. But this was a chip, a little hole that was made in that glass. And sometimes you might have seen maybe in a car windscreen, when a rock hits the car windscreen, it takes a chip out like that. Sometimes it breaks the whole windscreen. Well, I would like everybody to just, not everyone has hair like mine. I can look at a hair from my own head very easily. But if you imagine that you're looking at a hair from my head, don't pull any hairs from the heads of the people sitting next to you because that hurts. But have a look at the idea of just how thin a hair on your head is. Well, the European Space Agency reckons that what made that chip in the glass was a piece of paint, a little dust-sized piece of paint that maybe came off of another spacecraft or a satellite, maybe a long time ago, that was 1/1000th of a millimeter in size. So it was 100 times thinner than a hair from your head. Or if no one in your class has any hair, then maybe a hair from, you know, a dog or somebody that has hair. So 100 times smaller than a hair on your head. How could that damage glass? How could that happen? And the answer is velocity. Velocity, because things up in space are orbiting at 17,600 miles an hour. And if the International Space Station is flying at 17,600 miles an hour, and even a tiny thing is crashing into it at 17,600 miles an hour, the force of that collision, of that energy, can cause a lot of damage, a lot of damage. Space junk breaks things. Here are some pictures of actual space junk or holes that have been made by space junk. The one up in the corner that looks like a robotic arm, that is the arm on the International Space Station that they use to repair the station and maintain it. So that's a quite important piece of equipment. And there was a big hole torn in the protective covering of that arm by space junk. Probably a tiny thing, because they didn't see that coming. And then the other two pictures on the diagonal are solar panels. The reason solar panels are so important is because actually, when you launch something from the Earth, like a satellite, it needs to be small and light. Well, it's not small. Some of them are very big. Some of them are still the size of a bus. A lot of them, though, nowadays are actually just the size of, a big bottle of water or pop that you might buy, a big bottle of juice, that you might buy. And they can't go up with huge solar panels. So the solar panels have to be folded up neatly like origami. And when they are launched into space, the solar panels open up and then they get all their energy from the sun. Because you can't send them up with tanks and tanks and tanks of fuel because that weighs too much and it would be too dangerous. So solar panels are really important, but they get damaged all the time by space junk. This other picture is space junk that has fallen back to Earth, and some pieces of junk are big enough to do that, to fall back to Earth and not burn up in the Earth's atmosphere. But luckily, most of the pieces up there are small, and the pieces that are big, there are about 28,000 pieces of big space junk up there that nobody can control, but that we can watch with our telescopes and our ability to watch them from the Earth. But ESA estimates there are about 130 million to 330 million pieces of space junk that are too small for us to see. But they're still up there breaking things. And because I got to see Tim Peake last night, he was explaining that, about 6 times a year, the astronauts, well, many times a month, the International Space Station has to move out of the way of space junk that they can see coming. But about 6 times a year, they move, and then they can't see, something coming, but they see that there's a problem emerging, and so they are told, go to the escape pods and wait there until we tell you it's safe to come out. So the astronauts have to stop what they're doing, go lock themselves in an escape pod and wait for mission control to tell them that the cloud of debris has passed by, and it didn't cause any damage. And Tim Peake also was saying that when he goes outside for a spacewalk, when he went outside, you have to be really careful on the International Space Station not to slide your glove on what looks like a smooth piece of metal or anything, because actually so much debris hits the station that it's got those rough patches and holes poked into the outside everywhere, and you could very easily damage your spacesuit. So space junk breaks things, and this is really important that we find some solutions to that. Now, luckily, there are scientists and there are companies working on solutions. Here are 3 companies that are based right here in the UK. They're doing lots of different tests of new technologies to try and solve the problem of space junk. ClearSpace has developed a robotic grabber that can go up and grab it. Astroscale has designed this magnetic connector that if you put one of those on your satellite, then Astroscale can go up and take your broken down satellite and safely remove it from space. And Surrey satellite, SSTL, which is down here in Guildford, so not that far probably from most of you, they designed a test, a demonstration of technology called remove debris. And here's a picture of one of the things they tested, which was to throw a net around a piece of space junk so that you could safely deorbit it. All of those companies are inventing things and they're all here, but it takes so many people to stop us making an even bigger mess in space. We now have so many satellites launching, actually every week there are satellites launching, and we're growing how we use satellites and how many satellites are in space without really having the right rules in place and the understanding about how to stop that being a problem. So we need astronomers who can give us a better idea of what's up there and really look carefully at the space environment. We need physicists. I should say, by the way, that I know everybody on this picture. I have met them all except for the software programmer and the astronomer. I have met other software programmers and astronomers, but I haven't met those 2 ladies. But this gentleman, the physicist, he has designed a better way of watching big pieces of space junk using lasers. Software programming is so important because actually there's so much information and data that is being gathered that if we're going to understand how to keep space safe, we need to do a lot of computer science analysis of that information and be able to program the spacecrafts, the satellites, to get out of the way. And we need to be able to do that in an automatic way because there's no one flying that spacecraft. There's no pilot on board. This lawyer is here in the UK, and she is working really hard on coming up with better rules and persuading countries that we should agree on better rules and laws about how to use space altogether and share the space in space. Now, if your car broke down on the motorway, you wouldn't just leave it there for all the cars coming past to bump into it. But actually, in space, that's what we do. If a satellite stops working, we have no way of bringing it back. We leave it there with everything flying around at 17,600 miles an hour while it slowly, over a very long time, slowly makes its way back to the Earth's atmosphere. And there aren't any rules about how we use that space. On the motorway, there are a lot of rules. You're not allowed to leave your broken down car on the motorway. We all have to obey speed limits. We have to wear seatbelts. There are a lot of rules to keep us safe. In space, what we have is kind of good guidelines and ideas about how we should use space safely, but there's no law and there's no specific rules about it. And I won't go through all of the other pictures because of the time, but I did just want to ask if anybody had ever seen an Apple computer or an iPhone, because I really like this picture on the bottom. This is Dr. Marie Bajaw and Steve Wozniak and Alex Fielding. Steve Wozniak is quite a famous person because he and Steve Jobs were the two people who invented Apple computer, Apple iPhones, Apple iPods, EarPods, and all those other Apple things. So these are some very smart entrepreneurs who are making a new business, and the new business is going to make the Google Maps of space so we can all see much better what's happening up in space. And these spacecraft designers and builders, that's the team at Surrey Satellite, and that is the test spacecraft that they launched called Remove Debris. So there are lots of people doing interesting jobs, show some of them again, to clean up space and to help us not make a big mess of space going forward into the future, to design better spacecraft, better launches, and better satellites that are safer to operate and don't break down or can be recycled or repaired. But we need a lot more people doing those kind of jobs, a lot more people. So all of those companies that are doing that kind of research and developing new products like this, they're all looking for more people who can come and work for them. So that is a possible job for you in the future. Now, I'm going to stop talking and let you ask your questions.
Thank you, Katherine, for such an interesting and informative talk. Honestly, space, it certainly is a busy place. We can see there are many questions in our chat, and I will hand you over to my colleague Sophie to kick them off.
Okay, so thank you, Lisa. So our first question comes from Marsh Gibbons School, and they're asking, what would happen if junk fell from the space?
If junk falls from space? Yeah, well, it does actually sometimes fall from space. And people watch the big pieces of junk. If you think about it, actually, in the beginning, rockets were designed as a series of big explosions. They would do a big explosion to get up through the Earth's atmosphere, and then a big explosion to send the next part of the spacecraft on its way, and sometimes even another big explosion in order to release whatever it was carrying, which is called the payload, out into space. So it could get its solar panels out and start gathering energy from the sun to go on its journey. And all of those explosions left things behind. And some of those things were really big. So really big things like the body of a used rocket, luckily there aren't that many of them up there, but they've been up there a long time and they fall apart and they fall back to Earth. So what happens is when they fall back, luckily, most of them fall in a desert or they fall in the ocean, because it may not feel like it where you live, but a lot of the Earth doesn't have people living on it, which is lucky for us. So far, there's never really been any time when a big piece of space junk fell out of the sky and like landed on somebody's house. But there have been times when pieces of space junk have landed like in somebody's driveway. And so what one company is definitely trying to do, and lots of scientists are tracking these things, is to find a way of sending something up when you see that that is coming down. Luckily, before they hit the atmosphere, they don't fall very fast. They fall very slowly. So you can see them coming for a long time, for days and days and days and weeks. So there are companies trying to design solutions where they could launch up a little spacecraft that nudges that thing into a safer trajectory so that when it comes down, it lands in the ocean or in a desert. But most space junk is so small by the time it hits our atmosphere that it burns up and it never actually lands on the Earth.
Okay, great, thank you. Okay, so St Mary's class 5T asks, if we stood on a distant planet and looked back at the Earth, would it look like Earth had a ring around it because of all the junk?
Oh, that's a really good question. That's a really good question. I think because, most of that junk is small, actually, it wouldn't look like the Earth had a ring around it, but depending on how far away the planet is and how powerful your telescope was, you would definitely be seeing the satellites. And actually, you can, on a dark night, go out in a dark place. Now, maybe not in the middle of the city, but if you lived out in the country or near one of the dark sky areas in the UK, and there are quite a few places in the UK, down here by me in the South Downs, I can go up in those hills if I wanted to on a dark night. And what you would see is not just the stars and the planets reflecting light back to us. What you would see is satellites, because the things that are moving are satellites. And in particular, if you look up there on a dark night, and Elon Musk, who invented Tesla and is the owner of SpaceX, he is launching 60 satellites at a time on his own rockets to build his network of satellites. And when they go up in a line. So until they kind of move into position for quite a while, every launch he does, and he launches almost every week now, you see a line of 60 satellites in the sky. And you can see that with your own eyes. You don't even need a telescope to see that line of satellites.
Fantastic. Okay. Andrea from Smarden Primary School is asking, what will happen in the future if space junk continues to build up at the rate it is?
What will happen is that we won't be able to keep using space. I'm going to send out links to your teachers of some activities that you could do, some experiments you could do in the classroom. But if you try and imagine that you, drop something and it breaks into lots of pieces, and then you keep dropping things and they break into lots of pieces, it starts to get very congested. It's a bit like the plastics in the ocean. But the thing is that the plastics in the ocean, you could take a boat through them and it would not hurt the boat. But the junk up in space is moving very fast at 17,600 miles an hour, and most of it is made out of metal. Some of it isn't, but most of it's made out of metal. And so if a piece of metal is moving very fast and you have a whole cloud of those things moving fast in an uncontrolled way, the more satellites you launch, the more likely those satellites are going to get broken, the more likely they are going to turn into junk, and the more likely they're going to bump into something. And then you have a chain reaction. One collision makes another collision, makes something break up into lots of pieces, and those pieces bump into other things. And it's like a pinball machine, but where every time you hit something with a paddle, more balls come out and bounce around. So it could become, it could be that if we mess up space badly enough, we will stop being able to use any of those satellites. We will stop being able to put any more up. It'll be too crowded and too dangerous. And nature would clean itself up, but it would take about 200 years.
Okay, thank you. So I've got a question from St Bennett's Primary School. How many satellites are put into space each year?
Oh, that's a really good question. And I can't specifically answer it because it changes every year. If you look on the internet, you can find a graph from one satellite that launched in 1957 called Sputnik to the 13,600 that have been launched since then. And a lot of those, that graph would, make this kind of line, because so many of those satellites have been launched in the last 2 years. So in the beginning, you might have had, just big satellites that were very expensive to build and very expensive to launch, and they went and took up a position a long way from the Earth, and those were just, maybe launched a couple every year, or maybe one every other month when it started to become more frequent. But now, because you can build these very small, very cheap satellites, and there are lots of new companies, including companies in the UK, there should be the first satellite launch from the UK should be happening from a spaceport in Cornwall next month. So look out for that on the news. So many companies launching satellites, so many companies building satellites, so many companies building networks up there of lots of satellites, that by next year, that could be 10,000 satellites launched next year. I don't know. It's really speeding up. So try and find that information. That's a good piece of information to look at, because it's quite shocking when you think about how many more satellites have been launched this year than last year than the year before, etc.
Okay, thank you. So a student from Sissinghurst Primary has asked, what inspired you to become a space scientist?
Well, that's also a really good question, but I'm going to tell you the truth. I am not a scientist. I'm not a scientist, and I've never had a scientist job, but I do have a lot of respect and admiration for scientists. I work with a lot of scientists. I actually just got lucky. I got lucky because I was doing a job that did work with technology, but from the government, from a sort of business perspective, how to help technology businesses start themselves up and grow. And I was offered the job to be the chief executive of the UK Space Agency. And that was when I started to learn about space. But I was so fascinated about space. So many things are fascinating about space: the science, the technology, the services that we use every day down here on Earth that come from space. I didn't know any of those things just a few years ago. And so I just started learning as much as I could. And now I don't want to work in any other area because it's just the most fascinating area to work in.
Fantastic. Okay, so I've got a question from Leicester Heath School Swallow class. What kind of junk can we find in space?
Oh, you know what? I will try and find that link as well for Lisa to share with people, because there is a good, I think it's a National Geographic. I saw a website the other day that had 20 surprising things that you wouldn't expect to find in space. Most of the junk is broken bits of rocket and broken down satellites that don't work anymore. Most of it definitely is that stuff. But, astronauts have lost things in space. There's definitely a wrench. There's a camera. I actually think Major Tim Peake, the British astronaut, lost a camera, I think, on a spacewalk. And there's a few people who have wanted to be buried in space. So there are ashes, that they've asked to have sent out into space. So there's some very weird and interesting things up in space that you wouldn't have expected.
Okay, fantastic. So I've got a question from Meadowview School. How do they get the satellites into space?
Satellites are, as I said, we still haven't figured out any other way to get them except to put them in a big rocket. Although now, if it's a small satellite, you can put them in a small rocket and launch them up, straight up through the sky, through the Earth's atmosphere and into space, and then release them from what's called the payload. So if you imagine where your luggage goes on an airplane, or maybe like a big cargo ship that has those big containers on it. Those satellite launching rockets, they just have like a big space that is designed specifically to carry satellites. They take them up, they open the doors, and then they kind of push them out into space. And then everybody hopes that they can get the data signal, the radio signal, to identify back with the antenna on the ground that makes a connection with that satellite. And sometimes it's a little bit nail biting while people wait and wait and wait to see if they can find their satellite and make sure that it actually got launched properly. Sometimes that takes hours. And so, you know, if you're looking for your satellite and you're waiting to see, is it going to send a signal back? Have I been able to reach it? Is it going to signal, you know, because actually you can't see it with your eye. You have to find it with your radio, with your data connection. And then once you find it, you can start sending it signals to the computer on board the satellite to say, now you need to, you know, move yourself to where your orbit needs to be.
Okay, thank you. I've got a question from Ashton West End Primary Academy, and they would like to know, would you ever like to go to space?
Yeah, I get asked that question a lot, and the answer is no, because I suffer from quite bad motion sickness. So I don't even really like to go on roller coasters. And going up to space is a pretty rocky ride. And then when you're up there, there's no gravity. And so you float around, you might be upside down, you might be sideways, might be spinning left or right. I just think I would be sick the whole time. I wish I could go and see what astronauts see and look back at the Earth, because, you know, it's such a beautiful thing. But it's not for me. And actually, it's not for lots of people. There've only been, in the whole history of the world, fewer than 600 people who have actually gone out into space. There are going to be more, because in 2024, NASA, the UK Space Agency, and other space agencies have a mission called the Artemis mission, and they're going to take people back to the moon. And then there are also more science labs like the International Space Station, more laboratories being built by China and other countries. China's space station is now operating, and they already have Chinese astronauts living and working on that space station. So there are going to be more people going up there. And also there are companies designing space tourism flights where you're going to be able to pay a lot of money initially, but maybe the price will come down, to go on a flight up to space so that you can experience zero gravity and you can look back at space. And I think the more human beings going up into space, the more urgent it becomes for us to fix this problem of space junk. Because, you know, it's one thing for your satellite to stop working. It's another thing entirely for a bunch of space tourists to have their spacecraft smacked by some piece of junk that, you know, got left up there by accident, and put all those people at risk. So no, being an astronaut's not for me, but like, you know, 500,000 other people in the world, I really enjoy working in the space sector.
Right, thank you. Okay, so Rodborough Primary School ask, what happens if the crafts up in space break?
If the spacecraft itself breaks?
Mm-hmm.
Yeah. Well, what happens is it creates a bunch of space junk. And that does happen. As a matter of fact, recently, like one of the things that can break things in space, you know, space, it's amazing that we can even do this, because space is not an easy place to fly around in. And the sun, which is a giant nuclear reactor, every so often just spits out a big burst of magnetic particles. And that affects everything up there. It moves all the junk around, which is why it's hard to keep track of it. And sometimes it stops satellites working. And Elon Musk had a problem a few months ago where he launched his batch of 60 satellites, and they went out of the payload, out of the cargo bay, and 45 of them got hit by this kind of, we call it space weather, got hit by a cloud of magnetic particles. And he was not able, his company wasn't able to make the data connection to them in order to control them. And so they just slowly fell back to Earth. So just like that, they were released, and they became 45 reasonable sized pieces of space junk. Luckily, they weren't very high up and very far away. It didn't take them that long to deorbit, but it took them a couple of weeks. So that's what happens. It creates more space junk. If something breaks into pieces, all of those pieces are flying around at 17,600 miles an hour, 10 times faster than the fastest bullet here on this planet.
Oh, wow. So I've just got time. I think we've got time for one more question. And this is going to be from Chase Lane Primary. How do you clean up junk in space?
Well, that is the question I would like to ask you. I've told you about some of the research that people are doing and some of the work that some companies are doing to invent ways of making satellites safer and less likely to stop working. And actually, there are a lot of space weather scientists trying to figure out how to understand the space weather better so that satellites don't stop working. There are a lot of astronomers looking at the sky, trying to figure out where the debris is and how we can monitor and track it and watch it better. And there are companies building space junk collecting, satellites, and other companies thinking about ways of repairing satellites that have gotten broken and maybe reusing and recycling those materials up there. So there's an awful lot of interesting stuff that needs to be invented and lots of science that still needs to be figured out in order to solve that problem. So I leave you guys with that question.
That's wonderful, thank you. Well, we have had over 600 questions.
Oh dear.
So there's a huge amount of interest out there, which is fantastic. I'll just pass you over to my colleague Lisa. Thank you very much.
Thanks, Sophie.
Thanks, Sophie. Thanks, Katherine. I'm just so absorbed in everything going on here. It's been amazing. And as you said, there may be some young people today that may be those future inventors, maybe, jobs of the future that can all help clear up space junk. So thank you very, very much. Thank you everyone this afternoon for joining us. We will send you out some notes of all these wonderful links that Katherine can share with you. And we can also send you a really nice takeaway classroom activity that you can do maybe in another lesson. So thank you very much. Thank you for everyone for joining us, and we hope to see you all again soon.
Thank you all for listening and for your great questions.
Thanks, Katherine. Goodbye, everyone.
Goodbye, everyone.